All right, welcome back. And now we're going to start our conversation on harmonic motion, okay? So harmonic motion is another type of way of dealing with cyclic functions, periodic functions that we see in the natural world, for example, physics, okay? So look at this example. So let's say we have a ball of some mass attached to a spring. Okay, so we have a ball that is bobbing up and down on the end of a string. Okay, so if we have the ball just hanging there, right, it's going to be at rest. Let's say, assume it's at rest. And so this would be the equilibrium point. So we say that this is a system that's in or at equilibrium. Okay, so we would say equilibrium point is at 0 centimeters in this example. Okay, so let's say we're measuring everything in centimeters. And now if we pull the spring down, let's say we pull the spring down to the maximum distance or displacement of this ball without changing the nature of the spring, right? So we're not going to deform the spring, right? Where it's not going to go back to its original position, right? So again, that depends on the properties of the spring, right? But nonetheless, let's say we pull that spring to the maximum displacement without damaging or changing the spring in any way. Okay, so that would be the maximum negative displacement because it's going further in the downward. So this would be, let's say it's maximum 10 centimeters. Okay. And then also, let's say we just depress the spring, we push the spring as far up as it will go, and again, without breaking the spring or bending the spring or changing the spring in some form, where when we let go, it's still going to go back to 0, right? So that would be the maximum positive displacement. And let's say that is at positive 10 centimeters in this example. Okay, and so let's say we pull the spring to its maximum displacement, right? Maximum negative displacement. And let's say we let it go and it bobs up and down. Okay, so the ball assumes a maximum distance and the ball moves vertically up and down from its equilibrium position when it's at rest. Okay, so we're going to assume further that the time it takes for the ball to move from its maximum displacement to its, where it's above 0, to its maximum displacement below 0, again, going from here to here, we're going to say that occurs it takes 4 seconds for that, okay? Or excuse me, I'm sorry. When we let go of it, it's going to go back up and back down. So let's say for the ball to go all the way up here and then all the way back down here takes 4 seconds. Okay? So obviously with the ideal conditions of perfect elasticity and no friction or air resistance, right? Because obviously in the real world we have all those things. So if we let go, like in the real world, if we let go here, it's going to go back up to here, but it's not going to come back perfectly back to negative 10 centimeters, right? Because of friction and air resistance, right? But let's assume all those things are negligible and that it's a perfectly elastic system. Okay? And we're going to continue to move, the ball will continue to move up and down in a uniform and regular manner. Okay, so then the period, right, the time for one cycle, right, going from here to there and back again, that would be one cycle. So the period is going to be 4 seconds. Okay, the amplitude, right, is going to be what? The amplitude in this case is going to be 10 centimeters, right, because that's the maximum distance that it travels from equilibrium. Okay. And then the frequency, right? Frequency is defined as cycles per second, right? So we know that one cycle occurs in what? 4 seconds. So the frequency is going to be what? What do you think? Well, we just take the division, right? We're going to take how many cycles per second. And so since it's one cycle every 4 seconds, that means frequency be one fourth, right? 1/4 of a cycle per second. Okay? And so now motion of this nature can be described by what? By using a sine or a cosine function, and this is called simple harmonic motion, right? So this is called simple harmonic motion. And that's what we're going to study, and we're going to give the definition here in the next video, and then what we're going to do is we're going to do a couple of examples, and then we're going to go on to another look at a different type of harmonic motion. Okay? Have a great day.